right, so here we go. Here's the deal, ladies and gentlemen. Do you remember what contrapositive means? Negative p to negative q to negative p. So if my series is convergent, then the limit is 0, right? If my series is not if my limit does not equal 0, then I can guarantee my limit is divergent. That's what a contrapositive says. So I'm going to write this down, and you're going to write it down too. Yes. Converge. Yes. Yes. Mm-hmm.
The limit of the summation is the limit of the function.
Yes.
So what you're saying above, saying summation.
Yes. 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 They are two different things. The limit of the function and summation of function are two different things. The limit is the end behavior of the graph. If you think about it in terms of a graph, it is what does it go to as it gets really big. My sum could be bigger than smaller than that number because I'm adding up all the numbers, not what are the numbers going to. But that's the difference. Ladies and gentlemen, you do realize the difference between summation and limit? Summation means I'm adding up all those numbers. The limit is what are the numbers trending towards? The limit would be what are the numbers trending towards as they get bigger. The summation is I'm taking all the numbers and adding them together. That's the difference between limit versus summation. If the limit of the series does not equal 0, then the summation from n going from 1 to infinity of a sub n diverges. So that's the contrapositive. Because this is the same thing that says does not converge. Contrapositive means you flipped your statement and you've negated both pieces. That's what a contrapositive is. You flipped the statement and negated both pieces. So the statement was, if the series converges, then the limit of the function is 0. I'm saying if the limit is not 0, then the series does not converge. So what does say does not converge is diverge. Yes, ma'am. No, if you guarantee it's converging, then you guarantee the limit is 0. If you guarantee the limit converges, if you guarantee the series converges, the limit is guaranteed to be 0. You can't say if the limit is 0, then my function converges. You can't say the converse, and that's a really good point. You cannot say if my limit is 0, then I guarantee my summation it converges. You can't tell me that. Okay.
Is there an example for like it doesn't converge?
You're gonna make me think. Let me think on that one. I will find one for you. Well, you are. There's nothing wrong with that. There's nothing wrong for telling me that. Making me think. So, a reminder, ladies and gentlemen. This piece right here, this thing that we just did, is called the test for divergence. Because, ladies and gentlemen, if you get out the limit as n approaches infinity of a sub n equals d and e, then what? Or if you get the limit as n approaches infinity of a sub n does not equal 0, so it equals like 5. If it doesn't equal the number 0, then you guarantee that this series does what? Yeah. If you get out that it's 0, then you have to do more. Okay? If you get out the limit is 0, then you have to do more to see if it converges or not. And we'll talk about that. It's one of those, we have tests to do that. Everyone okay with that? Okay. Okay. Here we go. We're finding the sum of this geometric series. So the first thing that we should say is we should figure out a couple things. Number one, I actually told you it's geometric. But most of the time I'm going to say find the sum of the series. And you're going to need to tell me if it's geometric or not. Because when we're testing for things, you need to know several pieces. So, and actually I'll go back a step. I'm going to add a page in here. To apply a test for convergence, and we're going to have lots of tests, but we've done them for divergence, which is convergence. Oh, I can't spell today. The first thing that you have to do is you have to name the series. I.e., what kind of series is it? Is it geometric? Is it arithmetic? Is it what we call P series? You have to name what type of series is it. Okay? You have to name, and you're going to name the test. Are you using the test for convergence? Are you using the integral test? Are you using the comparison test? Are you using the ratio test? And we're going to do more tests, i.e. I'm getting at. So this is a foreshadowing, right? This has more pieces to it. Number two, you're going to state any preconditions. Some of the tests you have to state some stuff. You have to say, okay, this is true, therefore I can use the test. State any preconditions. What has to be used? What has to be used in order to use that test? Okay? Preconditions, we talked about those. We haven't called them preconditions, but number three, apply the test. Try the process of the test. Apply the process of the test. And number four, state the results. So state you are converging or diverging by the blank test. So you have to tell me you are converging or diverging by whatever test you used. Because we're going to start using more tests next class after. We're going to have multiple tests, yes.
What are the preconditions for the divergence test?
There are none. It literally is it, you have to write it as a sum, and does the limit. It literally, that is the limit. That has no preconditions.
So naming the series of the test and then
just go for it. Yep, so this one, there's just go for it. Simplify. Yep. Alright. So the first one. Okay, find the sum of the geometric series. We know it's a geometric series. Here's what you have to tell me for this one. If I'm just finding the sum, because I'm not asking you to find me does it converge or diverge. Well, we are going to figure that out. What's the first thing I should figure out? R. So I've heard several people tell me. Those you're like, how do we find the number? I've heard lots of people tell me what the number is. Why is it negative 2/3? Ladies and gentlemen, you take the next term and divide it by the previous term. 10/3 divided by 5 is negative 2/3. 20 over 9 divided by negative 10/3 is negative 2/3. Negative 40 over 27 divided by 20 over 9 is negative 2/3. So this is R. Write me the sum. Write me the sum formula next. So I want it in summation notation. Write it in summation notation. You are writing this in summation notation. Leave your phone on the table. Yes. Nope. I don't know her. I tend to do this one just because this way A is really nice because this is your first term. So I tend to do it this way. But I don't care. Alright, did everyone get this one? Here's my question. Does this series converge or diverge? Converging. Why? R is less than 1, therefore it's converging. Because this is a geometric series. If it's not a geometric series, you cannot use this statement. Neither one. Either one doesn't matter. You can do that, that's totally fine.
Okay.
Alright, so fun. You can find me the sum? You can see the same answer that I got. Did you get out 3 for your answer? Hey, what's the limit of this series or this function? Good, right? Because that's the if I guarantee convergence, then I guarantee I know what the limit is. All right. So if I want to state everything, I could say this converges. By, how do we test it? We test it by the geometric series test. Series formula. Technically it's a formula, but you call it a test. I recognize it was geometric series, therefore I figured that out. Alright. Ready? This one. Is this series convergent or divergent? Here's what I'm going to tell you. I want you to figure out if you know a way to rewrite this problem. I want you to figure out a way to rewrite this problem. Talk to your group members. See if you can figure out a way to rewrite this problem so you do not have 2 terms. I want a single term raised to a power. I don't want 2 things raised to 2 different powers. I want a single thing raised to a single power. I could have a constant in front of it, but I want a single thing raised to a single power.
Four times 2 yeah, that's 2. That's 4 times 2 is the same as 2. It's the same thing as this.
Yeah, you can't separate. You can't separate it.
No, that, no, this.
Ah, you can't do the same denominator. Or the same base. The same base.
Now it's 4 times. No, it's multiplication.
I'm gonna talk about it in just a second. I want you then, if you figured it out, great. If you haven't figured it out, I'm gonna have you try something else. I want you to figure out if it's conversion or diversion, if you can look at the numbers. So finally, write me the first 5 terms. Then we're gonna talk about also how to rewrite this. You should be able to rewrite it. The first 5 terms. Totally allowed to do that. Four n, 4 to the nth power, yes. Let's keep it the same time. Well, you can't shoot your 2 squared, raise that to the nth power.
Yeah.
2 n, couldn't I write those 2 squared? Alright. We're gonna talk about 2 different ways to talk about this. What's the first number you got? What was a sub 1?
4.
What was a sub 2?
16 over 3.
Third term? Fourth term?
2 to the 8 over.
Over what? Totally agree with this. Does anybody see a pattern here? Huh? That would mean, ladies and gentlemen, that R is 4 over 3. Could you write that as summation notation then? If I say n is equal to 1 to infinity, what are you going to write? Everyone okay with that? Alright? Now, let's talk about writing this. How else could I write this? For those of you like, I had no clue what I should do. Can I rewrite 2 to the 2n? Could I rewrite this as 2 squared raised to the nth power? Is that allowed? Which makes this 4 to the nth. Could I rewrite 3 to the 1 minus n. How? Same base as what do you do with your exponents? Add them, like do this. Okay. Do you agree that this is 1 over 3n to the nth power? And we're okay with that so far. I am going to move it down so that I can get to it. Oh, look! Wait. This has an n, this has an n. So I'm going to rewrite this as 4 to the n over 3 to the n times 3. Can't I write this then as 4 over 3 to the nth power times 3? Summation, n going from 1 to infinity, of 3 times 4 over 3 to the nth power. No, it has to be this. Because otherwise we will not get the right,
It wasn't.
if it's 1 here, then this goes to, these cancel out, and you get 4. But if it's 1, no, because these numbers are different.
Yeah.
And this will, that takes into account of these.
But then the 0 always went with n, and the 1 always went with the minus 1.
Normally, yeah. If you have the exact same theory, if you have the exact same number here, yes. Traditionally it does. Not always, but traditionally. Ladies and gentlemen, here's my question. Does this series, whether you use the red or the black, does it converge or diverge? Why can you then say this series diverges? Right? That's the value of 4/3 is greater than 1 by the geometric series test. As I figured out this was a geometric series, therefore I figured out that it diverges. We okay with that? Two different series, I got two different equate functions that give me out the same series. Right, one's got an n minus 1 and one's got an n. Alright, let's try the next piece.